Here we are in section 3.2 with our second example. We're going to be finding a derivative here as well. And our function is f of x equals the square root of x. And we're just told to find f prime of x. So that's the derivative function that's based on this f of x. Okay, so first things first, we'll start with writing our definition of the derivative. F prime of x equals the limit as h approaches 0, f of x plus h minus f of x over h. Okay, so we can see exactly what we're going to be doing there. That way we can just go step by step here. And first things first, plug in your x plus h into the function. So that would be the square root of x plus h. And then minus f of x is just the square root of x. And that's all over h. Okay, so at this stage, we realize why we covered chapter 2 first, because we've got to take this limit, and this is going to use one of our limit tricks, like one of our approaches to algebraically finding the limit here. You can see up in the numerator, we've got two radical terms there, x plus square root of x plus h minus square root of x. And so what we're going to do here is we are going to multiply by the conjugate to help us take care of this. So our conjugate is square root of x plus h plus square root of x. So do that to the numerator and denominator here. Okay, and so still doing our limit, h goes to 0. So when we distribute, we'll have x plus h, and then plus the two roots minus the two roots. We get that nice cancellation, characteristic of the conjugate. It's awesome. And then we have a minus x. So that turned out pretty nice on account of all those square roots and the conjugate distribution. Cool. Then down in the denominator, we've got h times our conjugate. There we go. Okay, so you know what's going to happen next. We're going to have some cancellation occur here. The x's are gone. And so we can even see at this stage that we're going to have h on top. All right, so we've got a h and we've got a h. Let's just go ahead and cancel those guys out. We know it's going to happen. You could rewrite the expression there if you wanted to, but we can see the cancellation. Okay. So we're going to have still our limit as h approaches 0, but now we've canceled out everything in the numerator, so that's 1 over our conjugate there, since we already canceled the h. Okay, and so now we're at that stage where we can use direct substitution, plug it on in, h equals 0. And we'll have 1 over square root of x plus 0 plus square root of x. Okay, which would be 1 over 2 square root of x. So that is the derivative of this function.